All right, good morning. Off to a slow start here today, that's okay. All right, how's everyone doing? Cool, cool. Yeah, Friday, it's good. Thanks for the pass. All right, so any questions? Got some requests for groups, so if anybody sent me a note about that before, like an hour ago, I've replied to you. All right. Well, let's just touch base on something related to scripting. I had a few questions about this. Um, so homework 7 is a bash script, and we like being able to break things into modules. In C, we just create functions. You can pass arguments to functions. You can get returns back from functions. In bash, you can pass arguments to a function by just listing them after the script name. Well, functions too, but if you're using one script to call another script, you can just put the name of the script, list arguments after it, and then the script that you invoke can access those arguments with $1, $2, $3, and so on. So passing arguments to a script, pretty straightforward. Getting arguments back from a script, not as straightforward. But remember, you can capture the output of any command by using back quotes. And anything that command sends to standard out will end up being the value of this variable result if you do this. All right. And so if you want to send back, one piece of information like a number, all you have to do is inside command, just echo that out, and that will go into the result here. So let's make a script, and then we'll talk about dates and dialogue. So I'll hop on. So let's say this is my script, and it's doing some fancy stuff. It's doing calculations, finding the duration of an appointment based on start date, end date, or whatever, right? And it ends up with some result that I want to pass back to the calling script. If I echo that from this script, I can do the following, right? And so I can test this by just running it from the command line. But now let's make a main script. So I can do something like x equals back quote CMD. And I'll output the value of it in an echo statement just to make sure we picked it up. And so if I run main, right, it picks up that value of 23 from command. And if command, does something different, right, main will pick up that value. So this is a generally useful structure, this back quote. And if I wanted to pass arguments, let's say my command is supposed to double a number. So I'm going to pass it 42. So I'm going to take the first argument, multiply by 2. That's going to be my result. And my main program calls command with an argument of 42. Right? It gets back an 84. All right, so it gets trickier if you want to return more than one piece of information. Right? Suppose I want command to be able to double and triple a number. So I want to take your argument, multiply by 2 and multiply by 3, and return both of those as the value of this command script. So I can do something like this. Right? So now I've got two results I want to return, result 1 and result 2. Well, I could do something like this. I could just return both of those with a comma in between. All right, and I can test this command from the prompt. I can say command 7, and I see it, returns the double and triple values with a comma in between. So my command function is good. How do I process that from main? If I just do what I'm doing right here, right, then my value of x is this thing with commas in between. But let's do this. So num1 equals, and what I'm going to do is I'm going to echo the value that I got back from my command. I'm going to pipe it into awk, and I'm going to say separate my fields with a comma, and I'm going to say print the first field. And that should set num1 equal to the stuff that came before that first comma. And then I'm going to set num2 equal to the same thing, but I'm going to print the second field. And then I'm going to print out the value of num1. And I'll print out num2 also. Right? So I've effectively gotten back two arguments from my script command. Right? I called command, I set the result to x, and then I broke it up into two fields, num1 and num2. Right? And so this is one option. And I'm separating with commas, so if I wanted to if I wanted to have a result that was a string that might have spaces in it, right? That's totally okay. Right? Num2 is my result has spaces. Right? And if I wanted my result to have commas potentially, then I could separate with pipes or tildes or, something else. You get to choose how you want to do this. Okay? It's your design. And unlike C, where, there's really one main way to pass arguments back to a calling function, which is return parentheses value, you can have a lot more flexibility in Bash. I could return a value through a file if I really wanted to. If I wanted to return a lot of information, I didn't mind creating temporary files. You can also return values through $? if they're small. So after I call command, if I want to return the value 77, I can just say exit 77. And as soon as I call command, I can save the value of $? That's the exit code from the previous command. I can save that in a variable. And I can print that out at the end and see what the exit value was. And it was 77. Now that only works for short ints. You can only go up to 255 down to 0. But certainly for a status flag, you know, success or failure, or success fail, something abnormal, right? You can do that, and that's what most Unix commands do. They give you a 0 for success, 1 for failure maybe, 2 for some unusual failure, etc. Right? So set it up how you like. You don't have to do it like this at all, but you know, this is one way. If I pass back a list of things separated by spaces, I can turn that into an array in Bash. We'll play with arrays in a few days, and then just access the elements, you know, by accessing an array. Or I can turn it into a hash. There's tons of things you could do. You can break it up with sed if you prefer instead of awk. So lots of options. All right, so let's see, question. Can you go over how to use the date format with the calendar widget? I don't know how to use date format with the calendar widget. You don't need to use it, though. So let's run our calendar widget. Let's spell it correctly. I really don't want to spell it correctly. All right, there's a calendar widget. Let's hit that. Right, so there's the date that came back. So it's a day, a month, and a year. If I want to grab the month, right, what can I do? Echo that, pipe it into awk with a separator of a slash, and just say print $2. There's the month. If I want to save that in a bash variable, I can just take that whole thing, put it inside back quotes, assign the result to a variable. There's a month. So there's also a date format switch you can put in the dialog option that will let you specify how you want the output arranged, year, month, day, etc., etc. And if you want to dig into that, go ahead and dig into it. It gets into some ISO stuff and so on. But you can also just take the date that you get back by default, day/month/year, and run it through awk, and pick up the individual fields. And if you want to use a JANFEBMAR instead of, you know, 1, 2, 3 for the month, well, you could use a switch statement, right, a case statement, to convert that, or you could make an array. We're going to talk about arrays. Make an array of month names, and then use this variable to index that array. So month name array bracket $month. Right, so options, and that's a nice thing to throw into a separate script. Make a script that you pass an integer, and it gives you back the name of the month. And now I could just say, you know, month name equals back quote script $MON. It'll pass that 11 to the script. The script will output November, and then my month name would be set equal to November. Right, and your time in this course, I think, is generally better spent doing rather than reading, right? So I don't want to discourage you from, you know, looking at the different switches and options available in commands, but you know enough, right, already to be able to do most of the things you need to do. But it takes some work. You have to put some things together. That's time that's really well spent. Right, getting better at putting things together, getting commands to work with one another. That's going to pay off a lot down the road. All right, so what else should we talk about? Let me talk a little more about curl. Let me give you some ideas of what curl can do for us. So I showed you, you know, my weather app yesterday for grabbing weather information and air quality. Let's do something simpler. Let's do curl, and let's go to the Linux server web page. And I like to put these things in quotes just because if there's special characters like $signs and stuff, we'll, well, $signs will still get grabbed. Let me put it inside single quotes just to preserve everything. So what is all of this stuff? This is the Linux server, right? This is this stuff. So let's take a look at that. Right. This is the directory of shared code that we have on the Linux server. And this is the HTML corresponding to that. Okay, so this is, you know, in the form of a table. So there's all these rows and table elements and so on. But for example, you know, more script examples, right? That's this directory entry right here. And we can drill down into this and do some reverse engineering of it if we want. But if you know what you're looking for, right? If I want this code right here, right? I could just curl that specific URL. And there's, you know, the contents of that file on that web page. So this gives you a way to pull down information from web servers. Theoretically, it also gives you a way to pass information quickly from one machine to another by posting it as a web page. Now, you may not want all your information to be posted as a web page, but you know, that's an option. Right, so here's a list of all the tags for the videos that I've recorded this quarter for this class, the other section, and 215. And so if you're on a Unix machine, right, I can just put in that URL, and there's a list of all the topics that we've talked about, right, along with the class, the date, the time, and the offset in the video where that was discussed. And so if you want to be able to look up some information, right, you want to be able to just say, you know, when did we talk about such and such, you could write a script. You type in whatever such and such is on the command line, and it goes ahead and does this curl, and it can take this and, you know, search for keywords like compile. Oh, we got to do something different though. Curl doesn't go straight to standard out. All right, so there's all the things that had COMP in any of the lectures. Or I can do, you know, grep -I says ignore case, and I can search for makefile. There's all the times that we talked about makefiles. So this is just a useful way, you know, so much of what we do is cloud-based and everything is so connected that it's nice to be able to, from a bash script, go out and access things from other machines through basically just, you know, a web access, a URL request. And so that's potentially useful. Um, if we go to Clark's web page, and I don't know about news and media, activities and events. So there's you know, upcoming important dates at Clark. So if I grab that URL, right, I can grab this and let's throw that into a file. Now we could do this directly with SED and stuff, but let's just throw that into a file and look for registration. And so here's, you know, November 13th, last day to register online for classes fall 2020. You have to speak HTML, right, or XML or something, but there's tools out there that will help you take this apart and pull out the hypertext references and the markup and get down to the core data. But you know, everything that's on this page is in this file right here. So if I want to know when there's no classes, well, you know, Veterans Day, and that's November 11th. So this is fun to play with, right? And it sort of opens up your machine beyond just, you know, what happens to be on our hard drive, and really opens it up to the whole web, and that can be useful. And I'm sure curl has lots of useful options, although I've never used anything except just curl followed by a URL. But there's ways to tailor it. And URLs are not just web pages, right? So URLs are also, you know, that's the old school way of accessing files using FTP, File Transfer Protocol. There's sites like that. And if you like playing with hardware and you play with, you know, IoT devices like a 8266, you can make these little devices put up web pages that you can interact with. So you put a temperature monitor outside your window, you can put that on the web, and you basically make a request with a certain field at the end of the URL, and it will send back information like, you know, the current temperature and humidity. Well, you can get to that really easily from a bash script just by using curl, right? Just say curl, put in the name of the URL going to your device, capture the output, parse it out however you want, and then do what you want. Print it, speak it, display it, you know, whatever. Or you can speak it, yeah. So I have a poll watcher running for Pennsylvania. So every time the count changes in Pennsylvania, it gives me a little verbal announcement. So and speaking is really easy in Linux. You can just say eSpeak, you know, like that. Let me turn up my volume here.
Hello, class.
All right. So, right. This is what's nice about Unix. All this stuff is built in, right? And you can access it all from Unix, which means you can use it in shell scripts. And if I wanted to speak the date, right, I can just put date inside back quotes.
Try not 6/10/28/16 PST 2020.
Alright, now it's got a funny accent, but there's all kinds of different accents you can put in. You can change the speed and so on and so forth. So, you know, you got different output options besides just printing it on your screen. I could display it in an info box with dialogue. I have generic monitors sitting on my monitor screen that that show me information. Let me do this. Right, so this is a generic monitor showing the current weather and air quality. This is my monitor showing the current vote tally in Pennsylvania. And those are just, you know, just running a script. So this is a script called PA2. It runs every 120 seconds and gives me information up there. So this is part of why I encourage people to be working in a Unix environment, is so that you can experiment with these things and be familiar with them. It's about customizing your environment. It's about using all of this stuff that we're learning, not just to make a high-low game, although that's, you know, cool in itself, but to be able to make your environment work for you, you know, as best as possible. All right. Let's talk about something that we've kind of been missing so far, which is how to read files from bash. We know how to write files. We can just, you know, generate output and redirect it with a greater than sign into a file. But the input side is not as direct. We can read the input from a file and send it to a command, right? But if we're in a script and we want to process a file line by line, how do we do that? So let's say we want to process a list of names from a script. So let's make a script name reader. And let's read this file called names. Okay, so so real simple syntax here. We can basically say while read, and we can call this whatever we want, temp do, and I'll just do, you know, temp equals angle bracket temp. I don't know, I'll just put a haha in the middle. And at the end we can say done. And if we want to read from a file, we simply say done less than, and we put in the name of the file we want to read. I won't do my haha, that's weird. Alright, so so this is like a regular while loop, right? Do and done. But it's, instead of while some condition, we say while there's more stuff to read from a file. So while read temp, and then each time we go through this loop, temp will be whatever the next line was that was read from the file. And then at the end, done less than name, that says, you know, read from this file, and when we hit the end of the file, then the loop is done. All right, I'll put the haha back. So name reader, and there's no such file because it's called names, so let me change it to name. So name reader, right? And there's the contents of the file. So that's a way to systematically go through a file one line at a time and do whatever you like with the input. And so, you know, if we're going to grab something from the web, we can use curl. We can throw the results of curl into a file, and then we could say while read, you know, variable name do done less than name of that file, and it would give us the contents of that one at a time. And each line we could just parse out. We could process it with awk or sed, or, you know, something more sophisticated, and kind of go to town like that. All right. So that's potentially useful. All right, questions on that? And I'm going to try to do this from memory, but this is not going to work the first try. Da, 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 da. Here we go. So I'm going to write a bash script here that that reads from the output of a command. All right, so I'm going to use the ls command, and I'm going to do this funny triple less than sign here. But you know, while read, let me change this to something more meaningful. I'll just call this file name. And if I run that, right, that lets me go through a list of all the files in my current directory one by one. Right, so I could run this ls command, I could throw the output into a file and then read from that file the way we did a minute ago, but we can also read directly from the output of a command by, again, using the back quote notation, which basically makes this a list of... Yeah, I don't remember why we have to do 3 equal signs. I just know I struggled with it for a bit over the summer, and 3 equal signs seem to make it work. I just take it as one of those mysteries that I live with for now. And it may not be necessary in all cases. I'm pretty sure 1 equal sign is not going to work, though, because I think it's going to try to open the files. Yeah, maybe you do need 3. Yeah, I don't know why you have to have 3, and I don't know what 2 means that is not as good as 3. Take a look at the man page for bash and see if you can find it, or let me know and I'll dig into it with you. But there you go. Yeah, it's a here string, and that's where I gave up trying to figure it out. All right, cool. Other questions? So homework 7, right? I'm hoping that you... I'm hoping it's doable enough that you know, it's not going to take a lot of blood, sweat, and tears for the next week to get it done. But I'm hoping you get it done, or get close enough to done earlier enough that you can spend some time having fun with it, trying to embellish the dialogue option, trying to add more features, things like that. And it's okay to go beyond the minimum, right? I mean, you're only required to do 3 additional features, but you know, it's certainly okay to go beyond that, and you know, try to implement different things. It's good practice, and if you want to get better at bash, you know, it's a good set of practice problems to implement some of those other features, and then you get to show it off to the class. So all right, well, I'm going to switch gears then, and let's start talking about regular expressions. And we need regular expressions to be able to really make good use of said, and to make better use of VI in general. So these are often called just regex. And regular expressions, they're a pretty important part of Unix in general. They're supported in C, they're supported in Java, they're supported in most languages. Perl was a whole language that, to me, was basically built around the idea of regular expressions. They're usable in sed, they're usable in VI, and we'll actually touch on or come in contact with some aspects of regular expressions in CSE215 when we talk about automata and formal languages, which is where a lot of this stuff comes out. And if you read any Noam Chomsky, his linguistic stuff, this was all about languages and, you know, trying to understand the structure of sentences and how do you describe the syntax of something. And regular expressions are tied into all of this stuff. So a regular expression is basically, it's a description of a pattern, right? And, you know, ABC is certainly a pattern, and that's technically a regular expression. That matches, you know, exactly a 3-character string consisting of A and B and C. A period C matches any 3-character pattern consisting of an A followed by anything followed by a C. Okay, but it would not match AC, right? Because an empty space is not considered a character. But a space would be, right? A space C, that would match that pattern. And there could be stuff before, and there could be stuff after, right? And this will still match. If I wanted to match a particular pattern, but I wanted to require it to be at the beginning of an input string, right, I can put what's called an anchor. And now this will match any string that begins with an A followed by any character followed by a C. So this is an anchor. And says what comes after it has to be the first character of the string. There's also a $sign anchor, which represents the end of a string. So if I tried to match ABC followed by a $sign, that would match any string that has an ABC and that C is the end of the line. So this is our other anchor, and that's the last character. We can also match collections of characters. So if I wanted to find a pattern that consisted of an A followed by anything followed by a C, I could say A followed by period star followed by a C. And the star means 0 or more. And the period star means 0 or more occurrences of this period, which a period can be any character. So this will match 0 or more occurrences of any characters. So this whole regular expression would match an A followed by 0 or more characters followed by a C. Alright, so just playing with those, just periods, period star, and 2 anchors, and regular spaces, what can we do? So here's a names file. So let's grep for an F in names. So it brings up, that's not a really great example. Let's grep for a J in names. So that brings up, you know, Smith, John Henry, and Jetson, George Awkward. If I want to find a line that begins with a J, I could search for a caret J, and that's only going to match Jetson. All right, let's see. Let's play with my bash RC. That always works better. Let's find lines that begin with a comment, right? So I can search for caret number, and that'll take me to a line that starts with a number sign. Let's search for lines that end with a period. Well, if I just search for period $, that's going to match a line that has anything as the last character. So it finds that line, but it also finds this, and this, and this, and so on. So a general thing in a lot of Unix, we can use a backslash. That's an escape. It says treat the next character literally. So if I want to find lines that end with a period, I can search for a backslash $, and that'll say find me a line that has a $sign as the last character of the line. So it finds that line, and then this one, and so on. If I want to find empty lines, I can search for caret $. I want the beginning of a line followed by the end of a line. And so that'll bring up these empty lines. And you know, if I have spaces on the line, it's not an empty line, even though it looks like an empty line. It's not beginning of line followed by the end of the line. And you can turn on, you can say set list in VI and see where each of your lines end. This is the delimiters I keep telling you to put around things, right? So I can see this is not an empty line. It's actually got 4 spaces. If I want to find 4-letter words separated by spaces, I can search for a space followed by any 4 things followed by a space. And so, well, found 4 spaces in the beginning. That wasn't what I was hoping for. It found the word with, it found the word more, it found the word size. All right, so we can do searches with this, and searches are really just the beginning of regular expressions. What we really ultimately do with regular expressions is we use them as part of substitution patterns. We say find this thing and replace it with this other thing. Okay, but the warm up to that is just using these regexes to look for things in a set of input. And so you know, exact characters, wildcards, that's a period. @ for the anchor in the beginning, $ for an anchor at the end. And then asterisk to say, you know, repetitions of the previous character. So if I want to search for a string of number signs, right, I can search for, well, if I search for $, or asterisk, that's going to match everything, right? Because this is 0 repetitions of a number sign. So is this, so is this. I'm hitting N to repeat my search. But if I search for a number sign followed by a number sign followed by 0 or more additional number signs, this will match anywhere that I have 2 or more number signs in a row, right, such as right there. Right? And if I wanted to get rid of all of those number signs, what can I do? I can say substitute a number sign followed by 0 or more successive number signs and replace all of that with nothing. And so that should gobble up all of these consecutive number signs and just get rid of them. All right. So Monday, I want to spec out a few more things about regular expressions. Really not going to be that much more. A way to look for any of a collection of characters by putting them inside brackets. And that's probably about it. I'm probably missing one more thing. But that's probably enough for using regular expressions to match patterns. And then I want to look at how we use these things to replace patterns with other patterns. And it can be a whole lot more than just, replace this with that. We can actually break the thing that we're matching into fields and save some of the things that match and use those in the replacement. And yeah, so I mean, I could do that, I could say $1, $, and replace, any comment followed by successive number signs with nothing, and then the $1, $, says do that everywhere in the file, and I just got rid of all of those. So now all my comments are actually, uncommented, which would be bad. Alright, but that's the effect of it. Ta-da. Alright, and remember, :Q exclamation mark gets you out of VI without changing the actual file, without saving your recent changes. Alright, so we'll dig more into regular expressions starting on Monday, and then we'll double back and start playing with sed in earnest, using regular expressions to process files. And then we'll go ahead and we'll take a look at awk and some of the more complex programs we can do with that. Alright, I will see you next time. Have a good one. Bye. Thanks.